Hi, welcome to the Ananda podcast.
Hello, thank you for having me. I'm Yassine.
I do prefer you to the other you've seen, just so you know.
Boy, is there another? Have you ever seen us two in the same kind of video or like place?
Was the hair to like
Little.
match him? You guys both have like beautiful locks.
Thanks. I'll tell him. I'll tell him that.
So I think we'll start with your love for learning. That seems like your meta area that you work in. I think with your YouTube channel, a lot of times you kind of use the Feynman method, which is where you teach things to people in like a way that they can understand it, and that's how like it makes it like a lot easier to like learn things like deeply.
Yeah, exactly. Well, it's not conscious like how I do it, but it's always how I end up doing this type of stuff. So to put some context, like I really like learning. Like not just in the I'm gonna learn this and this thing is gonna be fun. I like learning, like the concept of it, right? This is the stuff that I love, right? It's I can learn anything. Like I could be learning like how to fix a car. I could learn how to like it doesn't matter, right? The meta concept of learning, in my view, when I started to like be interested in stuff, was the most fascinating of all, right? And it really clicked in my head when I was in like this anatomy and cell biology course. It was like the second course, and I was sitting there, and then there was a class on like neurons, and I was already like interested in this stuff, right? In learning how it worked. But then like to just see like that's a substrate, like this is the actual stuff. Um, like I was like everybody was bored out of their mind because I don't know if you ever saw a neuron like in a histological setting. It's boring. There's like just white, like it's the actual neurons. It's very difficult to visualize them. But in my mind, I was like, yeah, this is the stuff. Like, look at this. I'm a whole bunch of neurons, like writing notes in here to not forget, like what we look like, right? Like that level of like kind of resonance of the material. From that point on, I was like, I want to push this to the maximum. So I started to like be very much more in depth to it. I pushed it where I was doing research in undergrad. Just like I loved research, but not necessarily because of like to publish a paper or get a PhD or whatever it is. It was really to like push the concept of learning even more, right? Because like in a research setting, it's like you have to learn, and like there's no way you can make it out if you're not learning something new, right? So there was always this, and like no one can really help you in research because you're kind of the one pushing here in this little corner, so you're the expert. So I was doing a whole bunch of that, and yeah, that's kind of my thing. Like every time I can like push this a bit further, I'm always like pumped and stuff. Like 2 days ago, I had a live stream where I was supposed to memorize the periodic table like in order fully in like 2 days, and I had so much fun. It was just so fun to be able to revisit this technique and then like to understand deeply like how what I'm doing right now is like hijacking my internal world model, and how like my brain is able to absorb content and stuff. Today I was going into my house, and I went to my parents' house, and I kept seeing this stuff, right? I was in the sofa in my parents' house, and I knew that like this was francium, and then just next to me was like casium. Like I knew this stuff because I was floating through it, and it just kept make me remember like how like this kind of engine that we have in our head is so powerful. Anyway, so I love this stuff, right? And if you push it to the maximum, right, like to the limit, the true version of learning is when you can then teach it, right, in my view. And you can teach it to as many people as possible in a way that it's useful for them and in a way that they understand. That's kind of the limit of it, because it's like the act of learning like self-perpetuate and then resonate to others. And if you can teach it to like a 5 years old, you did it, right? If you could teach it to like a 1 year old, good job. Right? So I don't know, like that level of how to say it, like propagation of learning in human. I think it's one of the most fascinating thing that ever existed in the whole universe.
Probably self-replicating self-replicating knowledge is like maybe like one of the most noble like acts or like things that you can cause to happen in the world.
Yeah, I think it's like fundamentally human. Like if there was a one defined trait of a human, it's like that stuff, right? Like being able to like figure out something, right? And then to make others figure out that stuff and to make them like improve on it, and like this stuff is absolutely insane, right? Like if you think about it, I'm reading research paper made by some dude, right? A whole group of people that like bang their head on this, and then I have new ideas and I can tell them, and then there's other researchers that like take this idea. Like that stuff is so cool. I think it's like one of the fundamental thing that we do humans that like is truly us.
I think it's very like it's like a smaller level of like evolution. It's sort of like societal like growth where it's like I think learning is also that way just as an individual for sure, where it's like instead of over like millions of years like certain things die and like eventually like the ideal thing comes to be, like the fact that you can do that as an individual and then also like propagate that through a society, it's very like small scale evolution, you know. I think it lets
Yeah,
us
well, if you want to go even like more further than that, like and push it to the limit, like if you think about it, really, like what we're doing, right, is that we're figuring out how stuff actually work, right? How this whole universe is actually working, and then you replicate through the act of learning, right? And then like you're making like the actual thing more, how to say it, like more visible, right? Doing that, and then you do it in a way that it keep propagating. It's not just you that understood like the whole nature of the universe. It's like we're all able to decipher this all together again and again, and it just go faster and faster. I don't know, but it's super cool. I think it's like the other thing is I think like all human, like whatever they say, they love that stuff. Like you can see it. Like it's like it doesn't have to be like deep learning, or it doesn't have to be like this biological stuff, whatever it is. Like every time I see somebody that is so deep into like their little thing, so some guy is like a fan of running, and then he will know like exactly how to do this stuff, right? Or like someone is they like to make like this type of pie, right? And they figured out like the chemistry how to do it well. I find it so interesting, right? Like so I don't know, man, so vivid, so human to be able to do that and to show it to other people.
I think like to me that's what makes humanity like really uniquely important is just that I don't think the universe has another chance of being understood, you know. I think it's
Yeah.
very
It's not a turtle that will do it, right? Not the whales. Maybe they do. Maybe they do understand. Like if we can talk to them, that would be nice also, right? I think Google did some stuff with the dolphin.
but I think the thing is like I think even if like an alien existed, I don't even if they had like human level intelligence, which I think it makes sense that intelligence would be important for like being evolutionarily like apex enough to like make it into space. But I think the like human curiosity, the inherentness like of that, I think that is rare and probably like unique to
Yeah.
Earth. That exploration was so important to
Yeah,
our
maybe. I don't know still, but yeah, like when you look at everything else, like that's kind of it. Like that's the stuff that like I don't know, man. Like when I think about what I want to do, really, right, and when it comes down to it, it's that stuff. Like if there's a day where I can push it and I can learn, like this is so awesome. And if you think about it, also in the brain, how it work, right? Like how because like at the end of the day, like we're primarily neuron, like the way you're like viewing the consciousness of you, right? There's many you technically because there you have many neurons and stuff, but like the neurons either die or like they survive, right? That's kind of it. You can have some neurogenesis, but like this is the usual stuff. And if you don't use like some of the pathway because they're not activated in some ways, they just die, right? And like you see these in people that like haven't like done a lot of like really intense learning in their life, and then like they just do the same stuff every day. At some point, like they kind of not calcify, but kind of. If you do an MRI on them, there's a lot of like, gray matter that just disappeared. And you see other people that like are not like that, and that they discover this joy of learning, and their brain is just like still so there. There is neurogenesis that happen when you learn hard stuff, but like it's not just that, it's just like there's less debt. There's just less debt in the neurons because the pathways are activated in all kind of different ways. So it's still all useful. And when you see these two people, one of them is like almost like, no disrespect to anybody like grandma or stuff, but like they're so robotic in some way, right? Like they kind of lost this flexibility and stuff, right? To the extreme where you get to dementia and stuff like that. Then it's like, it's almost, a person is completely gone, right? You can see that like they're not there anymore, except when you hit certain pathway, and then they're still there, right? Because that thing was still, everything else is gone, but like this one is still there, which I think like, I don't know, like because I studied all of kind of stuff with learning and neurons and like the brain, how it works, and like that's us. Like this is really us. Like this is how we were made to be. We're literally kind of like this machine that if you keep learning, the neuron keep like living, and then like you keep being you, and then you can help other people like keep doing that. So there's like some liveliness to it that is also beautiful.
Yeah, I remember when I was in India this summer, and there was my cousin's grandma. She was like sort of developing dementia, and she was around the same age as like my grandma. And I remember my grandma was like, "Yeah, it's because like, she didn't do anything. Like she just sat around her house all day, you know," which is unfortunate. But I do think like it is weirdly accurate. Like I've seen it, I think, repeat where it's like if someone is like using their brain. Like my grandma is like incredibly intelligent. Actually, like she remembers like a remarkable amount. Like she remembers my entire family tree, which is like insane. It's like it's really big. But yeah, I found that like actually quite intriguing. I know you did research with like schizophrenic patients.
Yeah.
Was up with their brain pathways that made them so sporadic?
It's difficult. It's just another type of, like, how to say it. Because there's a gradient to all of this, right? Especially with like neuropathy like this, and there's many cause and many way like this can develop to various extent. But if you think about it, it's just like one type of brain that can still work, but has these issues. And one issue that always is with that is like the issue of memory. Like they have trouble with this, right? It's like they have a harder time with their working memory and just their memory in general to form a new memory. So yeah, that's always the main issue with them. But like they're like most of the ones that I've seen, they were not in the like heavy case, right? They were still mostly there. Like it was like I think one of them was 35 years old, like not that old either. And we had nice conversation and all this because I had to teach with my colleague that was leading the project, them like a specific technique, right? And they were still there. It's just like they have these underlying issues, right? It's like the network is acting in a certain way, right? And like that acting in this way, where like the stuff that make us schizophrenic happened is viable, but you have these issues that they run into.
I know you have 3 kids. Was it like cool to like watch their like consciousness emerge? Like how did that
Oh, I
like
love it. It's so fun. It's so fun because like how to say it, everything is there. That's the thing with except the prefrontal cortex. Like this, like it takes time. It's like until 25 years old for boys. I have 3 boys, so like that's the setup. But like all of the machinery is there, right? And what's interesting is that like they don't know. Like the brain is really like a machine that is made to like pop off anywhere. It doesn't matter, right? As long as there's food and like it can go to figure out what to do, right? And then they just have this like innate urge to figure stuff out, right? They figure out how to walk, they figure out like where the food is, they figure out like the dynamic, they figure out like where people are, like they just continuously do that, right? Which is absolutely fantastic. And I have them like sparse, so I could see the same stuff at a different time. But also the interesting bit is for me was that like largely the way they are is already pre-made. Like there's kind of like a specific network type for these this human that is now made like this, right? It's like this is that type of human, and you see they have their own innate trait, right? There is this underlying machinery that is kind of the same, but then you have these strips that kind of change what's more easy for them to do and how they want to do it. Teach like a lot to me and then to other people that I teach, because like then you see like there's some limitation to each of us. You can go over them, but like there's a not a hard wiring, but like you can think about it as an already existing shape of the bowl or whatever it is, right? So you can put water in it and stuff, but like there's a specific shape to it, right? You can be flexible and try to overcome it, but you have to know that there's this shape that exists like deep down. So this is super fun to see for somebody that absolutely love learning, because you can see these things also emerge through time, and you can like test stuff with them also. Like I was just testing them. One thing that I did recently is I tested my oldest to be able to read without waiting for the curriculum in school. And what I realized is that he liked two things, right? He liked to be in motion. He liked also to be like with an adult one-to-one. And he liked the stuff to be kind of quick and challenging. Not challenging in a long period of time, but challenging in the now. So I did the whole thing with like flashcard, took a book that he liked and stuff like that, and I put every word in flashcards. And the guy was hooked. Like for 4 days straight, he wanted just to do that stuff. And like I was drilling him, and he was like, there's always something, and then it's like, it was what, like 10 seconds per card? Like then it was the next one, and then this one, there was a specific like sound, and then when the feedback loop was very high, and now he can read anything. Now he can read books. He can like he walk around and keep reading. What was super interesting here is that if you are able to hijack this like a certain tendency that you have or that the person has, and then modify the thing that you want to learn in a way that is easy to digest, like it will get in. Like there's no way it will not get in, right? And then when you reach a certain threshold of usability, right? Like then they have a certain skill, it just skyrocket, and then they just keep using it, right? So yeah, that's that type of stuff that is very fun to test out with them.
Yeah, I'd imagine. So speaking of experimentation, I know you did a lot of that with your PhD thesis. We can talk about that, or we can talk about like Axia, which I don't know, like I assume like you did enjoy academia because
I did enjoy it. It was not too bad, but like I'd say it was never the thing. Like I didn't go into a PhD because I wanted the PhD, which is a bit weird, right? I just wanted more time to do the research because I thought it was really cool, right? And so that's kind of why I did that. Because if you look at my stuff, I was already doing research during my first years of undergrad. Like I already found labs and I was just doing stuff, right? So that's the thing that I really liked. It was like at this point with PhD, you can just push it, and you can push it like however far you want. At the end of the day, you have to graduate or drop out or like do something, right? But what I really liked is that you can it really taught me to like take something and then just figure a way out. There's no one that can help you like when you have a PhD thesis and you have to get the job done. But also I learned a whole bunch of things of like actually how research and like discovery is done. And it's never alone. It's never like there's this one guy that just thought about it and then like he did the experiment in his lab at like 2 a.m. and there's a discovery and then you wrote the whole thing. It's never like that. Like this is a poor way of doing it. Like I never seen it work ever, right? And the actual thing that like taught me was that the learning can like reverberate over people, right? And this is so much more potent than just being alone and then like learning on your own. Because before that, like when I was in my undergrad, I liked to learn alone. I liked to learn my stuff and I knew stuff and it was super fun. But to truly put it to the next level, you have to be with other people, right? Yes, there's work that you do alone, you think about it, but then you share it. And then like people will tell you something about it and then they will learn something and then they go into do their stuff and then they're going to write the paper and you're like, wow, how you did that. And then like this just continue reverberating. And if you can like, I don't know, make it snowball and like make the feedback loop quick enough, right? With your experiment and whatever it is, this is where like actually the actual exciting discovery gets done, because you just keep reverberating with other people and then you break through like the barrier, right? Really. And that I absolutely loved it, right? Mm-hmm. And the thing is, I found the same in entrepreneurship. Actually, it's the same thing. Like I know academia, and then you have industry, and then you have entrepreneurship, blah blah. But if you take just a step back and you look at the stuff for real, right? It's the same meta concept that you have. You have to make a breakthrough in something, right? In your entrepreneurship journey, whatever it is, so that like you can like help somebody else or something else, right? By helping something else, you're able to extract some value that keeps on going, right? A bit like academia with the papers. You have to, at the end of the day, get the feedback loop going so that like everybody get paid and you can keep like keep the lab alive, right? Same thing with entrepreneurship. It's really like an organism, really. Like the two are like that, and they have this kind of value function that if they're able to do it, then they get either bigger, or they can stay, or they get faster, or they can get like, I don't know, like more resources to do other cool stuff. But there's the same kind of feedback loop, and at the tip of it is truly putting your learning capacity to really hit the unknown, and you're able to do that and be comfortable with it, and then like have this feedback loop that is fast and make it snowball with other people and reverberate it. Then this is where you can make a breakthrough and actually make something that is viable and so on, right?
Did you find that you could hit the unknown like way faster with the startup? Because I assume there's like less. I think like with academia, you have to like talk to your PI and get everything approved and like get a grant or something.
The unknown is, yeah, but like the unknown is not so unknown. Everybody know. There's no secret thing that you like the PI will come to you and say like, hey, I'm going to show you the limit of human knowledge, and then they bring you like, look at this shit, and then you look at it and you're like, wow, I never thought that this not this like that. You can do it right now. Take any paper that was published today, right? Look at it, go into the discussion section, and they're gonna say like, you could try this, we didn't do it, we didn't have time. This, we don't know. You can maybe do that thing, and then like, this is it. Like, there you go. You can plaster it on the wall. This is the unknown right now. It's gonna take 3 years before we're gonna hit that or like figure it out, right? It's maybe also the end. We don't know. Like these guys, they put their brain to it, and then they're like, yeah, this is the limit. We saw that while we're going this way. We saw this stuff. We didn't have no energy to do it. Like, guys, please help us, right? That's it. The actual unknown is just a bit different in in academia versus like in entrepreneurship, right? In academia, the unknown is static. Like how to say it, like it's really trying to discover the I don't know, hidden like hidden law of God or like the universe, right? It's what you're trying to look at. Like even if you look at the neurons and stuff, like you're trying to elucidate how this stuff works, right? And like if we all stop for 10 years and come back to it, it's still there. It has gone nowhere, right? Mm-hmm. It's this unknown is still there. In entrepreneurship, the unknown is mostly because like in entrepreneurship, you can help whale if you want to. They're not going to pay the bills. They don't care about that, right? They don't have any concept of it. So like there's another human that you have to help in some way, right? Like maybe it's the government you help by helping the whales, and then they're gonna fund you, and then this is the loop, right? This is the setup. It's like you're doing this stuff so that other humans right now, not like the dead ones, right? Or like the unborn ones, they're not gonna pay the bills, right? Mm-hmm. While in research, it's like everybody. Sometimes it's research on the history, right? Sometimes it's like the whole of humanity and like the hidden rules of the universe. But in entrepreneurship, it's much more dynamic because it's like it's now, right? And like the window is always moving, right? So if you're not helping people now, maybe they will not need help and it will be like a sad loss, or maybe they will not have the need afterward. Like there's all of this concept, but it's more intra-human. It's much more fulfilling in a direct way because like if you succeed and you help other people now. Versus if you succeed in like in academia, sometimes like there's going to be a guy 110 years from now that will be thankful for your thing, right? Really thankful. Meanwhile, nobody gives a shit. So like, you didn't help anyone really, right? Mm-hmm. You're just like discovering, chipping away at this, and then like it will be useful in some, how to say it, like very hard to conceive way far down in the future, or like maybe now, we don't know, right? This is the thing, like we don't actually know now. But entrepreneurship, it's much more dynamic and much more that's it, like gratifying to help people at the exact moment, right? And they're just like waiting for you to do it Because if they were not waiting for you to do it, let's say the market is in 30 years and you start now, you're gonna die. There's no way. Like, who's gonna pay for your stuff? The guy in 30 years, he is not even born yet, right?
Mhm.
But like, if you're finding a way to like do it properly, you get this feedback loop, and like at some point you see it moving, you see like the need moving and change, and you can still help a lot of people while discovering the new stuff.
So is the value that you found in entrepreneurship just like the way that you can help people? Is that like the main pull of it?
Yeah, definitely. But like, I got, to be honest, I got like pretty bummed down at some point. Like I was really burned out in my PhD because like I have this innate urge to kind of help folks, right? And at some point, because I was studying consciousness, right? And it was a very interesting problem, and we made like the whole lab made a lot of breakthrough in this. But like there's people that are minimally conscious or in a vegetative state, and sometimes they're just locked in their own mind, and we don't know which is which because all the tests for consciousness are behavioral. So if you had an accident, right, and then you hit your head, and for some reason you're kind of disconnected from anything motor, and it's like not really like the conscious process can't like touch this anymore. Like, what are people gonna do? Like, are they gonna let you live, right? Or are they gonna like remove you from the ventilator, right? And some people are truly not there. There's nothing happening, but like behaviorally, they kind of are kind of automatic and stuff. They can still open their eyes and move around their eyes. They can move their arms and stuff. But when you look at the brain function, there's nothing there at all, right? So this is a burden because at some point, if you don't remove the ventilator, the brain can go into like this respiratory brain type of thing.
So
And
like
then you have a literal body, kind of, but like it's like all the autonomic like system that kind of will work. The heart will beat, you're gonna breathe and stuff, but the brain will atrophy because all the cells that are in the neocortex are not being used because the guy is not there anymore, right? The network is like was too damaged, and like the whatever you call consciousness is fucking gone. So then everything atrophy, and basically what the family is left with is literally a body that is kind of just a body, right? Which is absolutely sad. Like it's debatable here, but this person should have passed away, right? And it's a difficult call to make because you don't know, and then the doctor don't know because they're there. The patient is right here. They have to make a call in 2 weeks, whereas the brain will pick up, and then you have the wife that is here that is bawling her eyes out. The kids came in to chat with the dad, and you have no clue, right? And you have to make a call, and what do you do? So that like absolutely wrecked my heart when I saw that for the first time. I was like, I want to chip away at this, right? And I did that. But yeah, at some point after like 5 years, I realized that like out of the 14 people in like, because we did recording, 14 people in my hard drive, like more than half were already dead, right? So I was like, okay, cool. I'm helping these folks, but like not them. They're dead, right? Like it's the other ones, and some of them recovered, so like they're good now. It's like the other ones, but like I don't know. I felt like the feedback loop was not fast enough to make the thing, and like I was nearing the end of my PhD, so like the only thing I was doing is writing research paper and writing grants, right? So I got pretty depressed there. So, but like what I found with entrepreneurship is that it's like now, like hey, I don't know if there was a business case or whatever, and then you were helping doctors to do that, you have to do it now, right? Like, otherwise, like it doesn't work. It's not a research project for 10 years. So I like this dynamism of being able to like make a difference in the now. And I think there's good in academia, but I got to believe, and I don't know if it's the right way to think about it, but like there might be a better way to do research in general, right? Where if you can find a way to self-sustain the stuff for now, you can do the stuff for now, but also help people in the future and like the discovery of new things. But like you can do it now, and help as much people as possible. So yeah, this is where I got hooked with entrepreneurship, and it was hard to kind of flip back to academia. I don't think I will ever go back to pure academia. If I wanted to make like some more intense research, right, to help some folks, it would have to be a mix of both in some way.
Yeah, I do think capitalism is like really cool in that it maintains this dynamic where everyone is helping someone just in order to like exist. I think it probably like keeps a lot of people from like being stuck in a rut of like, maybe eventually like in this very like abstract way.
Yeah, but some people love it. Like some researchers, they don't care really about the patient.
Mm-hmm.
It's like yeah,
Yeah.
I'm collecting
There's
data on this, folks. Like yeah, it's. Sorry, I didn't catch what
no,
you said.
but I think there's like a purpose to it for sure. Like if someone like wants to research red-eyed beetles or something, I think they should be allowed to do that. Probably.
Yeah,
Yeah. I think it's a small.
definitely, and like there's usefulness for it. There's usefulness for it, like definitely. But like at the end of the day, it's like you have to have a mix of both. I think in order to kind of make the greater impact on folks. Like you discover so much more, in my view, when the feedback loop is as tight as possible, right? Like as close to the effect as possible, because then like you know which direction to go through. The worst is when the feedback loop is super long and everything is kind of theoretical. I kind of hate that because I'm like, what are we doing, right? And like, if you think about it, like, why are we making papers and we're going this way? And like, yeah, but what are we doing, guys? Like life is short. What the heck? Like we're like, yes, maybe this is the way, but like, isn't there any other pocket where we can have like maximum value that will change the stuff, and then we can go in that direction after that? I believe more in this than these kind of long-term things and long-term projects. I think there's definitely stuff that can happen much faster, in my view, if people actually cared about it. And you can see now in deep learning, like how to say it, like to massive effect, right? Like machine learning pre 2020, 10, let's say. Okay, it's very interesting, but like it's math stuff, right? People didn't care stat math, and like there are some weirdos with like this concept of network that were more in neuroscience, if you think about it, than like anything else. People like didn't care much. It's like, yeah, well, you're doing this, cool, right? So what? What's it? But now with like the explosion that happened in 2015, like everything that is possible. There's so much more people that care about this stuff, and then there's so much more ways you can make it useful, that there's just so much that happens, and then everything just improve, and then it's just like exponential. Yes, sometimes it's too much and people are saying like dumbest shit ever, right, to get the funding, but it still has more dynamicity than like another field, right? Like where everything is dead and like people are like looking in a horizon of like 50 years. No, there's definitely value in like concentrating everybody attention and like how's it, energy into like a small slice of time. We saw that also with COVID, right? Never saw a fucking vaccine for like a virus happen so fast. Like I remember going to my lab, which was really next to like it was an hospital, and it was absolutely next to another lab that was doing like they were doing stuff for the bladder, right? They were studying the bladder. It was a bladder lab, and I remember they all pivoted to COVID research, like all of them, and they were so excited to be able to do that stuff and then to make a breakthrough there and just help, even in a tiny way. But then I was looking at this and I was like, it's everybody. Like it's these people. It's like these other people. Everybody get reconverted to like put all of our minds, right, collectively, and reverberate that stuff to finding a way out of this mess before like too much people die. It's absolutely insane. It's so much more how to say it, like fast. Everything happened so fast, and like the thing got done, which at the end of the day is like the thing that matters. Like now we have something like this. We have the mRNA vaccine. People said that it was not possible. We did it, and now we have this thing that we can use, right? Which it didn't existed before. And if like this stuff didn't happen, maybe we're not being this trajectory, and we not have that stuff being funded and be researched. Yeah. So I'm a big proponent of like short feedback loop, especially in an area where there's a lot of unknown.
I feel like academia, if it was an organism, it would not be maintaining homeostasis, you know?
Sorry, I think it cut a bit. I don't know if it's me or you.
I said, I think if academia was an organism, it like would not be maintaining homeostasis, you know?
Yeah, I couldn't hear you. Sorry.
Yeah.
There's a lag. Can you try again?
Hold up. All right. I was gonna say, I do think like definitely if academia were an organism, like it wouldn't be maintaining homeostasis.
Yeah. Well, academia is a weird beast because like it works. Like the whole thing works. If you think about it, it's like there's funding, right? And then like the government is giving a lot of it, and the university leverage these people that can create labs to attract the funding, right? and then they can use the fact that they have these labs to get the undergrad to pay more and stuff like that. So that work. And then on top of this is that each of the labs that the university can get can also like be how to say it, perpetuating, because by paying the journals to get their thing published in there, then they can have like a higher score, and then they can get more grant in the future, right? That's kind of how this whole thing works, which is okay. It's a way to do it, and it's like the only way that we figured out how to chip away at these like large problems that don't have like a direct impact now. But it's also create weird stuff. It's like you're sometimes you're doing research because you just want to publish the stuff, and because you have to publish. If you don't publish, the lab will literally die. So if you're saying like, no, I will not be that. Like I will make a lab that don't care about any of this, and we're gonna make good research that will have an impact in human life forever. Then you do it, and then you don't have anything for 3 years, and your lab will get shut down because you can't get any grant. And then the university will be like, yo, it was really fun, right? It's really, really cool. Get the heck out. You have like 24 hours. Like that's how it will happen, because that's the system. And like at some point, like I realized that like these groups of humans doing things is kind of creating another being of some sort, right? And that has different hierarchy, and sometimes it has other beings that are organism that are working in certain way. And like if there's a feedback loop that make this thing live, there's an input, there's output, and then there's something that they need to do to be able to work. It's much easier to understand like what the heck is going on. Because if you are just oblivious to all of this, and you're like you're the literal kind of thing in it, and then you're doing your thing, and you're like, why I'm doing this, and then you're so mad, right? Why do I have to write this grant? I was like this at some point. I was like, I hate this. And then I realized like, wait, if I don't do that and I don't get the money, like how are we gonna pay for this research? We have to pay folks, right? And I was like, okay, so the lab will have to pay this. But then like, this is hard because it's making a bet that we're gonna be able to publish. At least if I get the grant, then everything is break even, right? If I get to publish on top of that, that's a bonus that they can then feed to get more grant in the future. And then I started to understand this stuff. And in entrepreneurship, it's the same thing. It's just a different kind of organism, right? Malleable. It's not living in this. It can have different shape and form. But at the end of the day, it's like this organism has to attach itself to some sort of group of humans, right? To be able to have this feedback loop that where you help them, because they don't want to get attached for nothing, right? Otherwise, you're like a parasite or like a frauder, right? And then like they give you something in return for whatever it's like symbiotic. And if you do it well, you can maybe get a larger group of humans and get that stuff rolling. And it's the same idea. It's like, I'm gonna help these poor kids, all these students, and they're all gonna be all right. Perfect, good. You do that for like 6 months, and then no one will pay you. They will be very happy, and then you're dead, and nothing can happen. They will go back to what they were before. So there's still this kind of feedback loop going. And if you kind of is able to can model like the behavior of different like a group of people like this, it's so much easier to understand like what's going on, and like, is it something you want to do? Like in academia, is it something that you feel good participating in this organism and keep feeding it? Maybe there's another way. If there's another way, why? And you don't like that, why are you here? Do something else, right?
Yeah, I think probably like it's probably like very interesting to like decide that you want something done and then like see how that can be made profitable. I think people are doing that more often now than they were earlier. They're like, I want this change in the world, and this is how I can create a system where that will be a profitable thing.
Yeah. Because like they're like, it's not just like, it depends. Sometimes it's just this. So sometimes for like, I don't like software engineering is very interesting because there's this kind of open source movement that almost doesn't make sense from the outside. Like, where do you see? Yeah, you don't see lawyers doing this shit, right? You don't see like the electricians say like, hey, I've done it this way and here is it, and like you can use it, and like you don't have to pay for, like there's not this. But in software, it's like the thing are self-replicable, right? And it's like knowledge work. It's a bit like research in some way, and like literally like a research where you publish and you have your manuscript and stuff. It's kind of the same way. It's like I had this problem and it was hurting me, and I know it's going to hurt other people, right? And I will solve it for myself. But then I have the opportunity of like duplicating this, and everybody can do that now. And you can like on top of that, you can take it and you can make it better. So that like next time I'm gonna come back here, not only like my stuff will work, but it'll work even better than what I had before, and I will be happy about it, and everybody else will be happy about it, right? Like there's this kind of a like self-reverbating thing that like it's useful in the now, but it's also like more and more useful in the future, which is absolutely beautiful. I think that's one of the greatest sharing of knowledge that ever existed in humanity.
It's definitely like probably one of the reasons software engineering has grown to the extent that it has. What do you think like are the coolest things that you ever learned about like the way the brains work?
Oh, jeez. One thing I've learned that like absolutely blew my mind is you're not one, right? You're not one thing, which is absolutely crazy to think about it. Like, it's like so much fundamental. I remember the class, and I was there, and I was like, "Are we all hearing the same shit, guys?" Like, it felt like I don't know, man. Like when you watch Harry Potter, and then they're like, "I will now show you," like, and then they show something, and whoa, we can do that now. Like this is the same thing. It was like, wait, what the heck did they do to these people? It was like the long story is like the split brain experiment, right? And it's like there was these folks that have a sort of epilepsy, right? And like it can just go away if you cut the corpus callosum, so it's like in the middle, and it's very useful because you have two hemisphere and then they connect together, right? And then like it was just cut, and like people were fine. Like the brain is very redundant. But then they did a bunch of experiment on them because they noticed weird stuff, and like it's a weird like very technical experiment where they have to hide something and then they have to see it with one eye, and then the other eye has to do something, right? And like in the brain, like the visual goes into the thalamus, right? And then it cross, right? So whatever this thing see, like this one that is doing it, right? And whatever this one sees, like this one is processing it. And like what happened is like you're gonna say something, right? Because of what you see, but then what you're gonna write on your left hand is not the same thing, right? And when what they realize is that sometimes like what this one was able to see, right? This part of the brain was not the same thing as the other one was seeing. So the other one, like the other half that was kind of mute, right? You have one part of your brain that is more talkative than another one, was seeing the right stuff and was writing it, and the other one that was seeing it, but like it was not seeing the right thing, was just inventing stuff, right? But it thought it was seeing, and when he was looking at the thing that he was writing, it was kind of like self-inventing a story why he wrote that, right?
Yeah.
But actually, like it's two things. It was like two people in this they were supposed to collaborate and like a handshake and acknowledge like, okay, this is weird, but like this is the stuff we're gonna output that. They're not connected anymore, right? So they're kind of diverging a bit, which was super interesting, right? They're still connected in the sense that like when you don't do this experiment, they're seeing the same input, right? And they kind of can reason about like what's happening on the other side through proxy and stuff. But it was so fascinating because it's actually that like you can remove a lot of your brain and still be okay, right? Or you can like mess up a specific section that destabilize the whole network, and then you're not okay, and every part cannot work anymore. And when you actually look at it, it's just billions and billions of neurons that are working together, right? But like they work, and then they are in a specific network configuration that make specific type of a state happens, right? That was one of the coolest stuff, and like it taught me a lot about I don't know, like about ourselves, right? We like to think that we're just like this one thing, but it's so much more complicated than that, and like it's so much more almost like it's almost an illusion what you're seeing here, right? And it's like this kind of ongoing concert of neural activation that need to kind of be stable to be able to do the stuff and to live that is enacting. So there was this one thing. And the other thing that I found super cool, wait a second. I really wanted to say it, but I don't remember it.
Was it the arm thing with like the where people were like,
That's also cool. Like everything that has to do with like phantom limb and like pain and stuff is super interesting. Like there was this professor that was doing like these. Honestly, like this guy deserved like a medal of whatever, right? He was working on the hardest shit I ever saw. He was in the hospital, and then like he was studying like, these ion gated channel and stuff for the pain receptor, because some people are always in pain and there's nothing. Like it's not like they are burning every day, right? They like think they are burning because their receptor is all fucked. So they actually are feeling the thing that they're supposed to feel when there is a thing. Like imagine this. Like imagine like you're like okay, like there are people that went through and like they get burned all over their body, whatever. Okay, cool. But once they're out, they're usually okay. Like there's like all of the issue that associated with the fact that they were burned, but they're not feeling burned anymore. But these people are in like healthy body, but they feel like they're burning, right? Or like they're in total pain all the time. And there's nothing that can help because it's their own body that thinks that, right? The right pathways are firing for this. And it's such a evolutionary important pathway that like can't easily shut it off, right? So yeah, that stuff was pretty hardcore. Like there was this guy that was doing this. There was another professor of mine. He was like, I don't know how they did it. Like I don't know how like they can continue day by day going through this and knowing that whatever you're doing right now is not helping this person specifically, but maybe we'll find hope in the future for like for the next bunch, right? It's like there was this other teacher that had that it was doing like gene editing stuff. It's like gene editing like treatment and stuff to try to cure like children that had like a whole bunch of stuff in their genes that made them not live properly. Like they will die for sure, right? And then he was like trying his best to be able to edit a body that is supposed to die, which is absolutely crazy if you think about it. Like you take this 10%, like 1,000 years from now, in the past, this person is supposed to be dead. Like evolutionarily speaking, like it's sad, but like they are supposed to be on the pathway that dies, right? And that's it. But now we're at the spot where we can say like, no, we're gonna bring everybody forward, right? It doesn't matter, right? Like we're in control. We're gonna figure some way, and then we're gonna edit ourselves. Like we are gonna go in there and edit every goddamn cells in this body, and they're gonna move forward in time with all of us. Right? That's also I found like absolutely insane. The advance that we're in this.
How is the gene editing guy like? Was it like after they were born he was doing that?
Yeah, it's crazy shit. It's possible, right? It's really possible. He was doing like this CRISPR stuff, and it's basically like protein that you can give. I'm gonna butcher it, right? But it's like a protein that you can give mRNA, right? And like an instruction, and it will go and edit this out of everything that you can see, right? And if you're smart about it and how you're doing it, then you can just like trigger all the CRISPRs and just like get it all out, right? And then the person will actually have mutated out of their thing, right? Mm-hmm. And this whole system is very useful because like life is so fucking weird. Like if you think about it, like we're constantly being mutated by virus because that's their thing. Mm-hmm. Like these little things, right? I'm not gonna say they're bad because if you look at our genes, we're full of it. Like we're full of just the viral thing that came in at some point and it was okay and they were able to replicate and nothing happened bad. And then we just have like these like kind of graveyard of like a virus gene that came in and now for some reason they're turned off because of the randomness of life. But like there's a system in the body that can activate and then edit these out so that like whatever the virus put in and like insert itself, we can just edit it out because we done figured out like where their code was, and we're getting this thing out of our system so that we don't just keep producing these viral entities. So it's kind of the same thing, right? So we've discovered that and we're like, yo, we can use that, and then we just use that and to like start editing our stuff and stuff. This stuff is absolutely insane.
I do wonder though, like, because I know viruses have like a way to find which cell. So like cells on the outside, they have like markers that like say like what type of cell they are, and we're like very bad at like finding the type of cell to like target and stuff. Like as far as I know, like the cutting edge research on this is like it's not exact yet. So we haven't like mapped out all the different types. But I think because viruses are like very good at this, I wonder if you could infect a person with like a virus, but the virus has whatever CRISPR tech inside of it.
Yeah. I mean, like, yeah, you could technically, but like virus also, that's it. Like these stuff, this stuff is weird. Like, it's these type of like intellectual event. I find that I don't know, man. Like, it's the type of stuff that will make an atheist believe in God at some point, because you're like, what the fuck?
It's
What
very
is happening
good.
here? It's like you open a curtain that you're not supposed to see, and then like they show you like, yeah, look, this little spider thing, right? It just exists. Like, how it was made. Wait, they go in the cells, right? They eject the mRNA in there, right? So I'm like, so what is it? It's like, no, it's a capsule with mRNA in it. But you're like, yeah, but like mRNA is just like an instruction, right? Yeah. So it's a capsule of protein, which is like not a living thing, and then there's mRNA in it, which is an instruction, which is not a living thing technically, and then it goes and it hijack absolutely everything, go into your cell nucleus, in like snipe itself in it, right? And then it starts to produce the same thing, same instruction. So you're gonna hijack like all your ribosome to start spinning off the capsule, and then neatly packaging it with like the instruction, and then everything explode and you have more of them, right? Where is the beginning in this and where is the end? They're gonna mutate something, like sometimes they do mutate to be able to infect other stuff. Why is it there? Like, why do we have this shit? Like, who does it benefit, this type of stuff? So yeah, the virus stuff is absolutely like, when you start to dig into it and you start to realize that like the complexity of it, and also it is beneficial in some sense because it kind of increase, and there's some theory that like it creates some redundancy into your the gene, and like just expand it, right? Kind of add more blank space, or maybe like start muting stuff. But yeah, that's that type of this is one of the type of thing that like got me very interested in atomy and cell biology in the first place, and later on like everything kind of together.
With the psychosomatic, the guy who's like studying like psychosomatic diseases and stuff, was he figuring out like a drug to like stop neurons from firing like correctly?
It was like basically what this whole thing, it was because at the end of the day, one of the issue was there was a gate, ion gate, because like how the neurons work is you have like these gates, right? And the neuron is not a wire. There's no electricity in it. It's just like a concentration of ion that is different in like the outside and the inside. You have all sort of stuff to make this concentration there. There's pumps that can pumps out ion. There's also like there's various different ways that you can get like this concentration. But like what happened then is that if there's an impulse that comes in, or like if there's like some sort of stimuli that is supposed to open this gate, right? It will let ion in, and then like it will just do the stuff, and like it will create an action potential, and it will propagate the signal. But the issue in some of these folks was that when you were zooming in, it was like an ion gated channel that was messed up, right? And it was messed up in the wrong cells that made it always kind of fire, right? And like it was not recoverable. Like there's nothing you can do because it's not even like the touch, or it's not like, it's literally the cells that are like firing the signal have a gate in there that is malfunctioning, right? And then that is firing constantly. So it was trying to figure ways of understanding this type of protein properly, and try to find ways of like maybe editing it so that it doesn't do this anymore. Yeah, that kind of stuff.
I wonder if you could take like, I know for like SSRIs, it's like they use something that mimics like the normal like dopamine like I forget what it's called, but the normal like dopamine chemical, and so it like latches onto the channels. I wonder if you could like do something like that to just block or like act in the
Good, yeah, but it's like it's so complicated, these things, because you get ligand in there, and then you get like the dynamic of how this thing, because it's also like a physical thing, right? So sometimes they literally have a physical like ball and chain thing that can block it and unblock it, and like you have like millions of different type of channels, right? So there's like unintended consequences of like trying, if you try to block and you make a drug and you have a ligand that goes there and then just like will block this type of channel, but also happen to block the ones in like your limbic system, and then you just die. This is not good, right? So like it's very difficult to make something that targeted in the nervous system. So the guy was in the weed of it, and there's also it was just not just this, it was also other thing. And the issue with these is that, I'd say it, like these problem is like it's monstrous problem. It's like, imagine this, like imagine you were like this, but when you look statistically, right, how many people are like that? Do you know somebody like this? Like I don't, right? I've seen people like this, but I don't know them personally. So if you look at the stats, there's not that much. The pressure, the human pressure to allocate resource in order to figure this out is very low. So like there's very few labs in the world that is doing like there's all sort of these problems, right? So they are always trying to find a bigger pool of people to help so they can get funding and stuff in order to maybe fix this one problem, right? That's one of the how's it, the thing that I was discussing about, like I don't know if there's some mutation that happens for whatever reason, and then one of the comorbidity of it is that everybody is in pain, like they are on fire for like 100 days before they all drop dead, right? I can guarantee we're gonna fix this shit. There's no way we can't fix it, right? It's just a matter of allocating the human general bandwidth and our resources into specific problems. Yeah, that's the issue, and it's all kind of mixed up with stats and stuff, and like value that you can create rapidly. Yeah, that's a core issue with that type of problem.
Have you found with your company that allocating all the resources to like one problem is much faster, or do you split up where things are going?
Yeah, focus is everything. But the thing with when you do a company is that you can't just look at like one. You always have to zoom back to the organism, right? And sometimes the best thing for the organism is actually to not be focused, which is very weird, right? So for instance, if you're about to die because you run out of fund, and then there's this thing that you can focus on, and like maybe in 6 months you're going to be able to, because of the dynamic of your cell cycle, you'll be able to solve it and like be good. But you have 2 months of runway. It doesn't matter if you put all the brains, and even if you can add more brains, it will not do anything. Their cell cycle is six months. What are you going to do, right? So you're going to have to defocus a bit, right? You have to, okay, we're going to do this other thing, and we're going to get it quick, and then we know this will be faster. We're going to also like, do these grants and like get these loans and stuff. And then like you start to spread out a bit like your organism focus. But actually, if you look at the function of it living and growing, it's much better to do this than to do this other suicidal thing almost, right? Yeah, that's kind of the idea. Is like yeah, if you able to zoom out, you're able to understand these trade-off a bit more. A bit like the thing with academia, right? We could all just focus and then do this, and then like 5 years we're gonna make a breakthrough. Absolutely fantastic. So you're telling me for 5 years, no journal is making any money, right? The university is having nothing. The government will be like, what the heck are you guys doing in there? Like, we're making a breakthrough. Yeah, for sure. Everybody's making a breakthrough at the same time. Like nothing works in this specific scenario, right? So that's the issue, is like you have to take a step back, understand this stuff, and you can make it so that like in the long term you're more and more efficient. But that's what you have to look at. The organism live a life in the long term. Okay, maybe your organism is not that focused now. It's gonna live to see another day, and then at this point in time, it will be able to kind of change mode, right? Like let's say, for instance, you're able to raise big round. You have 10 million of funding. You have 100 years of runway technically. What are you doing trying to get grants, right? What are you doing trying to do consulting, whatever? Just focus on this problem. Do that. It will take you 6 months. Fantastic. Do that now, today, and then you put as much people as you can. And now the whole function of growth and of the value that you can create makes sense for this organism.
Where did you like? What do you think are the differences between like neurons and like human biological neural nets and deep learning?
Yeah, that's a good one, because I did a review of a paper for 1943 that was kind of trying to do like it's it's not even a deep learning paper. It's like an earliest attempt at formalizing a language. It's a propositional logic language to describe neural nets, and then to describe nets in propositional logic, like doing that both together. And very fascinating because, like, technically speaking, if you abstract a lot of stuff, they are very similar. You can actually model a neuron with an artificial neural network that is big enough. You can create neurons that are kind of as complex, like with the spiky neural network thing, as an actual neuron also. You can actually hook a neuron into a system that can act as a neural net also. Like the correspondence is there. But the one thing that is different between like an actual neural network from like a brain and then a deep neural net is that in a deep neural net sense, like nothing is happening at the same time. Like it's just all in sequence, technically speaking. Like when you shove whatever that you need to shove in the transformer, even if it has a trillion parameters, right? They will all go in sequence, and then that's it. In an actual biological net, it's not what every one of them is its own mini computer, right? If you think about it, it's like every one of them is its own mini neural network, because a neuron, you can only model it with like a neural network and a deep, an artificial one, like a deep one. So it's a whole bunch of mini MLPs, right? That are all acting at the same time, billion of them at the same time.
I have two questions.
There's no way for us to model that. Yeah, go ahead.
Okay, so does parallelism not make like do things at the same time and not like in sequence? I thought that was like what parallelism is that it can run multiple things at the same time.
It can run multiple things at the same time, but like they synchronize to do stuff, right? So like the neurons are like firing, right? And then they're like, in order to fire another neuron, in order to reach its threshold to be able to do an action potential, it has to do like either temporal summation or like spatial summation, right? You can model it whatever you want, but like that's kind of how it happens. But like from a purely technical point of view, it's each one of them its own MLP, right? A multi-layer kind of perceptron type of thing that is running kind of alone, right? But like all of them at the same time. If we were to model this right now, I don't think we have even enough GPU in the whole world to be able to do that for one brain. And you see a bit, how to say it, like not the miss, but like we're not there yet in my view. It's like we can try to reproduce and like by simplifying some stuff. Inherently, you have like a living mini computers that can also change, right? That's the other thing is like each of them can change now and change their chemistry, their way that they're connected, and then in a very dynamic way through each millisecond that passed, which is absolutely crazy. And I don't even think we can get that close, to be honest. I think like the coolest thing we could do is figure out how to make these things like not want to kill themselves, because neurons are like very difficult to keep alive outside of the brain. They have like as much mass of astrocyte that kind of keep them alive than actual neural mass. If we can figure a way to like keep them as their own like computing unit outside of the brain and make that like efficient, I think like it will be a very good substrate for like a computing technology of some sort. And I think that's where we're gonna be able to get something that is like truly or intelligent and stuff like that. But now we're getting closer to like, is this even ethical to do this shit? And then like, I don't know, man, like this is weird. Like if you think about it, like taking some of my neurons and then we can maybe reproduce some of them. And then we have like my giga brain with like more neurons that I have in my head. Like, is this thing is for sure alive because it's go from my brain?
I think we do more things.
We're going into weird territory here.
We do like more inhumane things to like rats. Oh, and like I think rats have like more neurons than like a petri dish with neurons in it. You know?
Yeah.
If you find like the neuron stuff inhumane, like you should also find like the basic animal experimentation inhumane. You know.
The human neurons are not the same as the like most other neurons. Like it's very weird. The human neuron, if you take them out and then you can hook them up, you can actually learn the XOR function. And so there's a specific function that like a perceptron can't learn, like an artificial one, but the multi-layer perceptron can. But in a human neuron, one neuron can do that. And when you see the same in the rat, like they can't do this. So there's actually it's not like a wire that is exactly the same in every animal. So if you remove ethic from the thing, if you want to make a very good computer from like a biological substrate, why the hell will you take a rat which is dumber than us, right? Or like even a dolphin, a whale, right? You will take the like prime, most intelligent thing in the world, and then you will do like this in as much computing unit as you could, that you could afford. So in my view, like yeah, we can make a rat computer, but like it would be make much more sense if we can make like a human neural computer. But I'm not saying it's ethical, and I'm not saying we should do it, right? I think there's people that are working on this, but I'm making no statement about whether you should do this stuff or not.
Did you see the little thing where like the neurons like played Pong? I thought that was really cute, actually.
Yeah, and there's another experiment where they took a slice of a rat brain, right, and they put it into a robot, and it's like controlling the robot.
But
I don't know how this like was able to clear ethic, but it's absolutely wild. You have like the remnant of the rats is now stuck in this robot, right, for like I don't know what, like 6 hours maximum before like it just died. Like its last activity is just like controlling this robot in this maze.
my other question was, you said that a neuron was like a computer in and of itself. I was thinking it's more like a MOSFET, no, where like it has like different possible like inputs and outputs, but like is a MOSFET a computer?
What? Sorry, I didn't catch that.
MOSFET, like the where you have like multiple transistors and like you can have like gates and XOR gates.
Oh, okay, yeah. It's a bit more complicated. It's a bit more complicated than that. Like yes, like it is technically behaving as a wire, right? If you think about it, because it has this kind of all or none a threshold where it will actually fire, but like it's changing stuff, and it is able to learn a thing internally. And if you really dive deep into it, it has a whole chemistry associated with it. It can change technically like the conductance of the wire by having astrocyte wire up with him in like swan cell that we call it, and then like you have like this annealing sheet that makes it even better at firing, right? It can change how like its dendrites are connected, its potency. It can change like the vesicle stuff that it's creating for sending the neurotransmitter. It can do a whole bunch of stuff. Imagine if your wire could change itself, right? That's kind of the thing. It's like, and also how it reacts to different type of input, and like how it transform stuff. So it's a bit different. Like honestly, as soon as you open it up and you look at like the ion channels, for me it was always the time that I was like, wait, hey, well, what is this? Like it's literally a literal gate, right? It's like it has its own how to say it, like a kind of dam and stuff, like and this is the stuff that dictate how stuff move. And if you think about it a bit, like it has to create these things and jam them there. So there's a whole machinery that is not just on the near the limit of the neuron, but everything inside to make this stuff work. Like okay, the synaptic vesicle at the whole end of the axon will shoot neurotransmitter. Fantastic. It has to make them in some organelle somewhere and transport that stuff all the way there and continuously do that, because they can't be depleted. If they are depleted and there's nothing there, they're not going to fire anymore. Whatever happened with the action potential, there's nothing going to be released. So there's this whole dynamic that is so much richer than just like, it's an on-off wire, let's not talk about anything else. Like, no, it's actually going to express protein in different like concentration, and like it will be able to make them and then make some that are maybe different depending on what's happening. It's wild. It's pretty wild, yeah. And also like it has a whole gang of astrocytes feeding this stuff in order to be able to work, right? So there's all this signalization in the neuron that make it say is that like, hey, I'm worthy, right? Just make me not die, right? And then there's like these other cells that are like, yeah, let's put all our energy on this one, fuck this one. And then they do that, and then it's able to survive and do stuff. You don't get that in a wire. Like in a wire, and it's not like guys, help me out, and then like there's something else that is helping it out. Like no, it's just either working or it's not working, and if it's dead, it's removed, and that's it, right?
So would neural nets be just like an on-off, just like 0 or 1, and there's like, could you not simulate like what's going on within a neuron in a neural net?
You can simulate that, and this is where you get like the concept of like liquid neural network. There's a whole company that is doing really well that is like on this premise. There's also like spiky neural network, right? Where they kind of simulate the action potential and the whole dynamic. You have the continuous thought machine from Second AI. I really like this paper. That is also kind of in the same vein, where each neuron is now a multi-layer perceptron on its own. It has a history and stuff like that. Yeah, you could simulate it, technically speaking. Mm-hmm. It's just hard then, because like as soon as you try to do that, right? As soon as you try to simulate stuff happening for real, and you don't have an engine that is running at the same time, right? You don't have like a 1,000 GPUs for each of the neurons like firing up and doing their stuff. You're gonna sacrifice parallelism for sequence, because like these things lives in time. They are like their stuff, and they need like the temporal summation. They need like stuff happening like through the actual hour of time. And this is hard to train, because one of the cool thing with transformers that we have is it's a good model to do massive parallelism on it. So in an instant, you can learn a whole bunch of stuff and change the weight, right? It doesn't have to be sequential, let's say like other type of architecture. But like these specific type of architecture that try to reproduce the brain without the right kind of computing substrate, you either have to make like the most complicated GPU farm ever, right? Or maybe think about changing a substrate, or be patient also. If you are patient and like you're just okay with taking the time that it takes, and like changing stuff in like a pseudo okay way, you can maybe grow an intelligence like this. But yeah, I think like in my view, like the more I think about it, the more I think there's going to be a push at some point to have another sort of computing unit that is not like silica based, but has these properties that we already know works. Like we already know a neuron work. I think this breakthrough will come from, I don't know, man. I think it will come from like some pharmaceutical lab that will like, hey, we invented a way to keep the neuron 100% sure they're gonna survive. And then there's gonna be some nerd that will be like, wait, I'm gonna take that and then grow a bunch of neurons and then like put them in serine parallel, and we're good to go. We have a new computer now, right? It's so much more powerful. It's like you have a billion GPU in your computer. Who doesn't want that, right? But like, if you think about it, your computer now has name. It's like Steve or something, right? It's like a thing.
Yeah. I mean, I don't know. We were kind of raised off of like Jarvis from Iron Man, so I don't think people would be like that weirded out by it. I've always like wondered like,
yeah, but like, I mean, Jarvis is Jarvis, right? But it's like a computer program of some sort. Mm-hmm. But imagine like, I don't know, man. Imagine closing your eyes, right? Mm-hmm. Okay, fantastic. Now you're a computer for some dude, right? Like that's kind of the issue that we have. Like, because like, you remember what I said, that like we're not one. We're kind of like a mixture of like all of these neuron dynamic and whatever. I don't know, man. It would be like the act of putting a baby in a computer and like, yeah, you're running your thing. The baby is connected. It doesn't like, don't worry about it. Is fed. It's all good. I think there's gonna be some, if we're doing this right, that stuff. I think there's gonna be some big ethical question you're gonna have to ask ourselves. Is it worth the compute, right?
I wonder if you could make the neural net without like the part that like wants like to be their own thing, like where it just like wants to serve. But it's also like, how do you differentiate between that and like something that just can't articulate the fact that it doesn't want to be there, you know? Like I don't know that you.
It's hard, man. It's very hard. Like, and you have to understand that like your brain is not just a neocortex, which is kind of what we are right now. Not really, but it's like if you look at the illusion of what an actual human is mainly the neocortex. But there's so much more. There's like all your limbic system. There's like everything that is inside that makes like the stuff work on a daily basis. There's the thalamus that is like directing everything. Like there's a cerebellum that just make the movement make sense, right? There's all of the proprioception that you have. So like, I don't know, like this is what I'm saying is like will this thing be alive technically? Like, is it missing too much to be that, or is it gonna still be that, but like it will know that it's missing something? Because you're taking something that is supposed to work in a specific system, right? It's supposed to work in like a specific setup. This is what the genes are made for, and then you're putting it into something else, and this is why they keep dying and they don't want to live or something like that. Like every biologist that ever worked with neuron know that these guys don't want to be there. They want to be either dead or somewhere else, right? So like they will die. They're forced, like keeping these guys alive is almost impossible.
Mhm.
So I don't know. Like I think that it's a very deep question that we have to ask ourselves, because it's not just that. I think it's like we are technically like all of this layering, right? And if you have ablation in all of these layers, there's like you don't look really like a human, a full one anymore, right? You're a bit like missing something. So if we make a computing unit out of like one part of it, I don't know, man. Like if this thing is alive or not, but like I think we just have to stop a bit and ask a question here. Like if there was a petition somewhere to stop and think, I think that would be it, right? I think like everything's silica based. I'm like, I don't care, man. What the heck? This is like sand. We're just like running more computation on sand. Wow, the sand can now do more complicated function. Nice, right? But in this particular case, it's not that. It's like you're taking something that is supposed to be somewhere else, right, and driving it, and then you're hijacking it to do whatever, right? Like, and it's alive. What the heck, right? Let's stop and think a bit.
I mean, I don't know. Like, I think silicon eventually, like, if it can simulate like carbon-based life.
I think you're starting to lag again. I can't hear you. Try it again.
What were we talking about?
Neural computer. I think that's enough of neural computer. I was thinking like babies on the computer and stuff. Okay, that's a.
But I was though. I remember the last like podcast interview that I did. I was talking about like I not in like an evil scientist way, but I do think that biology is definitely like the next frontier for a couple reasons. But one of the reasons was like it seems to me that it's a lot more efficient. Like the fact that our brains run on vegetables and like the amount of energy that you need for a GPU, I find it like surely like scaling the amount of neurons is going to be much more effective than like scaling the number of.
Depends because like the brain do consume a lot of energy if you think about it for the amount of computation it's doing, but like it's doing different type of computation. It's not the same thing that like a GPU is running. And like if you were really to put them two by two like at the same time, like what you're gonna do? You're gonna like benchmark it and like how many matrix multiplication these GPUs can do versus you, and then just gonna time somebody and like calculate the amount of sugar that his brain like it was able to get. But I do agree. I think like honestly I think it's gonna be a mix of both. I think like having like these efficient approximation of what the brain can do is fantastic, right? We should have that. I think that's definitely something that the humanity can produce that is good. But then there's also like, yeah, I think scaling, I don't know, man, like scaling an actual like a network is also feels so much more powerful because you already know it's gonna work technically because that's what we do, right? But in our case, in order for the neuron to survive, they have to be in a case that's like has a certain volume and stuff, right? Mm-hmm. And shouldn't be too big because then how the hell are we gonna get out, right? Mm-hmm. And like it shouldn't be too small because then there's not enough room to like do stuff. Mm-hmm. And it shouldn't take too much energy because otherwise you're gonna have to feed 24/7. There's nothing you can. So there was all this balance that mm-hmm. like I don't know, the evolution we hit the right kind of thing, right? But I think like if we're able to get out of there and able to use the substrate, right, that we kind of created to kind of make something else and then take care of it in a way that like doesn't have the same like value function to survive, I think we can make something truly intelligent that is different. But I think it's going to be harder than we think. It's not just going to be like I'm going to put a bunch of neurons in series and parallel and like hope for the best. I think I don't know, I think like it's the stack, in my view, of how this brain function that like makes us, right? Anything that you see remove, right? You can have a healthy neocortex. If you don't have the hippocampus in there, there's nothing can happen, right? Like like there's literally nothing. Like there was no new memory that can be formed, and the person will be lost most of the time, right? There's a lot of this stuff that like it's like a micro issue that makes the whole network kind of garbage. Like it is kind of this, like it kind of like look a bit like what the human can be, but it's missing something so critical that like it does actually not. You can see directly that like there's some big issue, and like maybe we're gonna do that at first. We're gonna create the first, I don't know, neural computation unit, and then like it will be able to do stuff. But then you can ask it something else, and like it doesn't work really, right? There's something missing, and it doesn't understand. I don't know, like humor, whatever it is, and we're like, what the heck is wrong with that thing, right? And the thing is, I had this belief when I entered neuroscience was that I still have. It's like it literally didn't change, even with like the advance of deep learning. Like the most advanced machine that we have in the whole universe right now is the human brain. There's nothing coming close to it. Like nothing. If we just look at organs, the human brain is like top notch, right? And if you just look at like machine, like it's not even close. And like any system, this one is the most complex and like most I don't know, most interesting at the end of the day. So it's kind of like, in my view, always going to be the frontier of what exists.
Have we tried making like a neural net like off of like a different type of transistor that might like be
Yeah, there
popular
is
neurons?
there's this other kind of transistor that I think it's called neuromorphic or something like that. Is it that? I think that's I think it's neuromorphic. It's brain-inspired computing system. It's like this, like you can change the transistor and then do that. But I think at the end of the day, it's like approximation you're gonna try to do, right? Yeah, you can do it in various different ways. I don't know, with gas and whatever the heck, lasers. But like, you're gonna approximate that thing, right? I think we're gonna circle a bit and like dump a lot of money in it. And at some point, we're just gonna stop and like, okay, let's bring a computational or a scientist in there and try to make this stuff live, right? Try to hook it up properly, right, guys? Let's do that, and then let's make some. Because if you think about it, we already made one breakthrough, which is like you actually don't need to go and pick up neurons. You can take whatever cell and make it change its lineage so that it can hit the neuron lineage. Like you take any cell, even your skin cells, right? Like it's the same DNA in each of them. It's like the same big instruction. It's just that each of the cells will take different slices of it, right? So you can technically take one and just make it express the neuron lineage or whatever neuron lineage you want, and it will be able to express it. So we already have this first big step that is not trivial, right? Now it's just about like trying to make them live and like trying to hook them up properly. It looks simple, but it's actually not. They don't want to do that.
Is that what a stem cell is? Where they like you can change the lineage from a
A
stem
stem
cell?
cell is a cell that is purpose built to like replicate itself and then like create all of these different cells. It's kind of this, but it's a natural way for the body to do that, right? But it's different. It's not just that. It's like all this issue was purely regulatory, right? So what happened, like I'm gonna butcher the story, but in a nutshell, what happened is that there was a ban on like using stem cells to express neurons, right? Like there's just like people were like, whoa, wait a second, this is not right. We should not be doing this. And like the researcher was like, yo guys, we're trying to cure cancer here, right? Like we're gonna have to do it. There's no way we can get to this without doing that. They're like, no, this is wrong. You guys stop it, right? And then they were like, okay, fine. We're not gonna touch this cell. We're gonna take the skin cells. And they're like, yeah, skin is skin. I have skin. I'm shedding it every day. And they're like, okay, we're gonna do that. Take the skin, transfer it into a stem cells, right? By changing some of the expression, and then make it jam a neuron. We didn't touch the stem cell technically. We touched the skin cell. So they found a loophole. But this whole thing is purely regulatory, right? It's because we decided like, yo, we should touch stem cells, and then the researchers are like, perfect, I'm not gonna do that, and I'm gonna do this loophole, and then we can express anything we want. Like it doesn't matter, right? And to the point that like, even if you take the stem cells, it's like a shortcut technically. So yeah, it's kind of related to this, but we took it a step further.
That's cool. So like all of my cells like could be neurons if I wanted them to be.
Yeah.
That's cool.
Yeah, because technically, if you think about it from a purely computing perspective, like it's really well made. It's like here's everything, right? Because I always start with everything, right? Now we're going to reproduction. It's like here's everything, right? And then each cells will, instead of trying to have different genes and you take that and wait, you take, well, am I the same thing as you now? Because now I have different gene. Yeah, we're the same. Like, it's gonna be a clusterfuck just to trying to figure this out, right? So instead, with the progenitor cells that decide to be what we are today, decide to do is that we're all gonna have the same thing, right? This way we always know that we're all the same, guys. But we're all gonna have different jobs, because the other ways, why would it be one blob of amoeba and then just be like one thing, right? Like, we have to diversify. I need some legs in there. I need something that can chew. You think, right? And like you're gonna like pump some oxygen in here because it's gonna get dense. So you have to have this diversification. And how they figure this out is that you have the same genes, and then some of them are expressed and some are they not. And the way to do this is a bit weird. It's like you have this histamine, that's how it's called. It's like a coil that can make some part of the gene denser and like not being able to get touched by whatever machinery need to read the instruction, and some that can, like some that are unrolled, right? So it's kind of like this unrolling and not unrolling. And there's other kind of stuff, like there's all the epigenetic of like putting literally like some molecules in some part of the gene setup inside the nucleus. So yeah, that's kind of setup. So you can technically shift this around, right, and like move this coil and then move change the molecules, and you can technically express make a cell change to be something else, because that's kind of what happened when you have like these stem cells, right? They're gonna express something, but then they're gonna align it this way, and then express something else. Like, you're gonna be this thing, and then like this is how they're able to replicate. But they have to do this, and also make sure that they shut it off so that it doesn't reproduce itself. There's this whole game of like only these cells can do that. The other ones can't, please. Otherwise, it's gonna be a mess. You get cancer like this if they don't want to die. Yeah.
I know it's like some sort of molecule that like makes the DNA like coil up a little bit. So when they're transferring them like from skin cells to neurons, do they like remove that like molecule or protein or whatever they're using?
Not that, like, they can't go this deep, right? So it's more like trying to redo the job of what the stem cells is doing, right? But at the spot where the cell is not like that. There's many pathways to do this, but conceptually you can think about it as like, let's make this more like a stem cell, right? And then let's make it move and do something else, and like create another cells that will do that thing, right? So that's kind of the motion in rough manner that is happening. You can't like really, if you think about it, we can't go that micro into the genes and like literally move stuff around, but you can influence the cells to go into these other modes, because that's kind of how the cells work. Like, they work a lot with signaling, right? And then like something will tell it to do something. It's like there's this signal that is given, and now they do that. For a good example of this is like when cells need to kind of suicide themselves, right? There's other signal that tells it like, yo, you did your best, stop right there, and then like it will just kill itself, right? We call that apoptosis. So it just do that, and try to not go into a necrosis where it just open up and then just like everything goes out. Because if everything goes out, there's a whole lot of signal that is noise that can fuck up everything. So if you do apoptosis, what happens is that you're like you do it to yourself as a cell, and then everything is kind of neatly packaged into vesicles that can then be eaten up by the macrophage. So that's kind of one expression of this is like, if you signal, and the signal is usually simple, because if it was too complex, right, it's just gonna be a mess to do that. So then when you're trying to do these kind of changes in the cells, roughly speaking, you're trying to hit that one thing, right, and then hijack that one thing that the biology is doing naturally in order to express that. Sometimes you have to do it in chains and stuff like that, but that's kind of the idea how you can like influence these cells at such a deep level. But you have to understand the pathway, right? Like, if we tied it back to what we said at the beginning, some dude had to spend like 20 years like figuring out this specific pathway for like how the stem cells are changing into neurons, right? 20 years, and people like, why are you doing this, man? Like, just do something else. Like, no one care. Guy died, right? And then sometime in the future, 60 years later, we're like, ah, shit, we need to express neuron now. We can't do it without. And then like, hey, but like, I've seen this paper, and then they read it like, let's do it like this. And then they do it, take like 4 years, bypass the whole thing, like, we did it, and then they move on. That's beautiful also. Like that's also something that is beautiful. And like, I don't know, every new information that we can glean out of these type of system, they have an intrinsic value. Like definitely they have an intrinsic value. But you have to be some like, either like this stuff so much that you don't care, right? Really, you don't even care about the usefulness of it. You're like, I just want to like know that, right? Yeah, we need all sorts of people.
How does like matrix multiplication become like something that can think? Like, how does that turn into?
Yeah, that's a good question, right? But you can think about it like anything, right? Anything that like, there's this concept that like any complex system is greater than the sum of its part. There's emergence all the time, like in everything, right? You can think about like I don't know, like bees are a great example, because like bees are kind of like an organism. We have like literally a queen that is expressing different things, but it's also not just the queen. It's not about the queen. The queen can die. It doesn't matter. It can make another one.
Mhm.
But like, she started it all, and then like then it has all this stuff. And then if you see the behavior of these things, they can talk to each other. They can just like wiggle their tail until it like go left, and like they wiggle their tail until it like where stuff are. Same thing with ants, right? They can talk chemically to one another. They can remember the path that they went through, right? And then the colony can learn about the surrounding and stuff like that. But they can also kill themselves. Like if they're not useful, they're just gonna like go where they should die, and they just die, a bit like a cell. But like, it's not about each of these individuals. It's like there's now something else that is emerging from that, and that's what we see with like the deep neural network. The only thing that is weird is that we see that in silica. It's not a living thing, right? This thing is not living. But like, I don't know. In my view, it's like, it's normal, right? It's like, you can see it even in like a smaller system where like the stats which are aggregate of different computation, make something that look very smart, but then you hit the out of distribution setup, and you're like, oh yeah, it doesn't know about that. For sure, it's just like a bunch of stat, and like it does this. So any small scale experiment that you're doing like this with like some kind of learning, you see that really clearly. Wow, and like I love learning now, and I love this stuff because I made like a sentiment analysis NLP. Wow, with a bag of word, mom, right? But you never think that this thing is alive or has consciousness or whatever it is. It's just like these things have, if you think about it, like if you just stop, right? They had the chance to see a heckload of functions of how we communicate and how we express ourselves, right? A lot of them. And when I say function, is like, if this happens, then that, and then if this other thing happens, then that. And this thing that is gigantic is modeling these functions and can recombine them in different ways. And this can really trick you into thinking that it's alive. It's like, yeah, like I'm giving them this input, and it's able to do this and that, right? But at the end of the day, like, it's very easy to see like that they're not really, because as soon as you fill up the context too much, right? And like all the computations start to fail because the system is not like, it's right now it's not made for like mega context. So it gets lost in what it said. There's no memory also, because everything gets passed one shot. And if like you want to have a conversation that continue, the output go out and then it's passed one shot again. Like, it's not like now it has memory of things that has passed. No, you're still jamming the stuff, and then the weights are lighting up. And this thing doesn't know you. It's still the same weight. It hasn't changed. There's no adaptive learning going on. So, I don't know. If you open these up properly, and then you study a bit like the attention like mechanism and like the context and how like the computation are doing in there, like, you find it super cool. Very cool. But you're never going to say like this shit is conscious, right? Like, there's no way that like this is what's happening, right? In my view, it's like, maybe we gave enough data, and then we have a model with enough capacity to create enough of these function, right, that we are able to model what the prototypical human would do in this instant, right? That's very much closer. You want to call this consciousness, or like that we model consciousness? I don't care about that, right? But like this is not a living thing. It's not like a something that has a being or anything like that. Yeah, but that's how it is. Like it's emergence of like many phenomenons that are getting added together. And once they add it together, it's not like they are just that. They're something else.
But I do wonder, like, if we understood humans to the extent that we understand neural nets, like artificial ones, would that also feel like this isn't like really doing anything? Like it's just doing like this and this.
This shit is complex, man. I don't know. Like I understood truly how complex it is when one of the smartest teacher I ever saw. I realized that she spent like 30 years in like a sub problem of the neuron. Like she was literally studying one organelle. That's it, right? It's 30 years of brain computing power going into this stuff. Her and other people, right? And then they're like, yeah, this is all we know. And like it was a 3 hours class, and I was like, this is it? Like 30 years, we're done? It's like, but there's so much more to know. And I'm like, Jesus, we're never gonna get done with this. And it's fantastic, I believe. Like, I think like we should not make light of like how much work did it take to get here, right? Of course, if you're thinking about C. elegans, like the worm that we use as a model of for neuron behavior and whatever, there's like 128 of these neurons. We know every one of them. We know how, when, and how they connect each other. We had got this one mapped, right? This one we can model it 100%, right? But like, look at this. It's like a small worm. You can barely see it. And then it took all of our brain power for like 1,000 humans to figure out what the heck this thing is doing. And it's neuron. So you just take another small jump in another like organism, and people are like, oh, this one we don't know. Like, this one, it's gonna be very hard. There's like millions of years of evolution that needed to happen in order for this stuff to be there, right? And then like it's acting in such a complex way that can do all of these other things. I don't think we're really near figuring out like exactly how this whole stuff works and to model it in any sort of way that makes sense, right? Like yeah, I don't think so.
I know we like have modeled like a fly brain, I think. Like I wonder if could we have a machine that does exactly what a fly would do in like any instance? Like have we tried that?
Yeah, we could. You could do that. That's not too bad. Like a fly, I think it's a bit more complicated than the C. elegans, so it's a step further. But like, it's Drosophila melanogaster, right? It's a very tiny fly. It's not even the big ones, right? It's like it's super tiny, right? I knew people that work with that, and I was like, this is it? It's like super small. Like, yeah, fruit fly is what I'm doing, right? I can image the brain, and when you see the image in journal, it's like, whoa, you can see that. When you look at it, it's like, that's it. That's all we have. So yeah, even like rats and stuff, it's impossible. Like these things are so complex. Anything that like you start to be visible, there's just trying to model what the heck is going on is difficult.
So you said earlier that like human neurons are different from like rat ones. So do all animals like have different neurons?
Every neurons, like a lot of neurons in your brain are also different than like there's a whole variety of them. So there's this like diversity in your own brain, and like they all have different specialization. It's also what I was saying. It's like not just one wire, and even with the same family, they also have different expression and they can change. Right? So you get this diversity, and also in the different like animals, you don't have the same ones because technically speaking, you can't. It's different genes. Mm-hmm. The genes are not the same. It's not the same like code substrate. So yeah, they're not similar.
That's cool. We mapped out like one neuron of like a human
For like fully mapped out like the whole neurons, everything that's happening within it.
Mm-hmm.
Like there's still like organelles that we don't know what's up. Like trying to like do imaging on organelles, like the sub component of a cell. Yo, it's so hard. Like you're doing this weird microscopy thing, right? And then you realize that within this organelle has like a whole system. Like I don't know if you ever saw like the Golgi, I think it's called, apparatus. Like a, yeah, it's like all wavy stuff, and it's like with vesicles and thing like that. And like I had one teacher, he was only doing this. He was only doing imaging on that, and then doing change, and then seeing what's up. So tiny. And then there's others. There's a whole bunch of other type of organelles that are all different. And then like on the surface, like with the of the neuron, there's so much happening here. There's all the receptor in there. They're all the lipid that create like the skin of the neuron, all the channels that they express at different time, right? Like these things are so complicated, you have no idea. Like cells, like it's insane. I think we're gonna make something out of them before we understand how they work.
Is the myelin sheath like an organelle, or is it like a bunch of proteins?
No, it's not a cell. It's actually not a cell. It's the Schwann cells that like go and then wrap themselves, and that's their life now. So it's a, like, you think about it. It has a nucleus and all this stuff, and now it made the conscious decision that like, you know what, this axon with this neuron, I really like them. I'm gonna live my whole life here, and my only purpose in life, my only purpose is to make this tiny gap, right, in action potential go a bit faster. That's all I do. And then there's a whole bunch of them that just do that, and they're alive, right? They have to be, and then they do this stuff. That's the only thing. It's just like they are literally an insulator now.
How do you get energy like ATP to like neurons and like myelin sheaths and like things like that? Like, what's like the pathway that?
There's a whole circle to do that, but it's also an interesting topic. We're far from everything, but like no, like make you think how complicated everything got, right? When this one cell decided, like, you know what, I'm gonna let this bacteria enter. I'm gonna let in, right? And I'm gonna let it like live. I'll feed it a bit. I don't mind. And then like it did that, right? This one was like, it was not cycle like the other one and tried to kill it. And then like it just like duplicated and stuff, and now it has more. But it turns out that these guys are super more efficient than us to make like ATP and energy. And so like we didn't just do whatever we're doing before, like with like the very little amount of ATP. So this one cell now was super good, right? It can do a lot more stuff. It had much more energy to do like all the chemistry that it needed to. And then from this on, they're like, you know what? Now that I have more energy and I have these guys, I can also reproduce these guys. I don't mind. Like every time I'm gonna divide, I'm gonna make more of them, and then we're good to go. I'm gonna keep some of their like DNA so that like they know that there's something, and we're just gonna be one, guys, okay? And then it did that, right? And then it created like this multicellular organism that can kind of talk together, and like they have to coordinate now. So everything is more complex and stuff. But it all started there, right? And they all have this, right? This is how they're making this is what we say, like mitochondria is the powerhouse of the cells and whatnot. That they all have the same kind of machinery, and they're doing the same thing. The only difference with neurons is that they need so much more energy, so much more like nutrients from the outside to nourish them in order to fire these things up and have enough of the stuff that is running. Like much more than the skin cells, let's say. Like the skin cells' only purpose is to fucking die. That's all it does, right? It get born, and then they're like, whew, good, I'm alive. And then like it gets shredded because it's like hitting everything. It's like the UV, like abrasion, all this stuff. And the only purpose is to join this thick layer of dead skin, so that like the organism doesn't have anything that is entering his stuff. Yeah, that's the situation for these guys.
Yeah. Yeah. We can end. I know it's like been 2 hours. I don't want to like waste your time. But yeah, I'm supposed to like learn CUDA by like Monday, so I should get on that.
Cool. Get on that.